Example of a random variable. Again, a random variable is a variable that takes on values with specified probabilities. In this example, the American roulette wheel has 38 pockets labeled 0, 0, and 0 through 36. There's various versions of the roulette wheel, but so anyway, this is one of them. Some wheels only have 1 0, or some of them maybe have a triple 0. There's various slight variations on it, but the standard American roulette wheel has 38 pockets. Pat bets $2 that the ball will land in pocket 31. If Pat wins, then Pat gets the $2 back plus another $70. If Pat loses, then the house keeps the $2. Let X be a random variable representing Pat's earnings. So okay, so either Pat is going to lose $2 or Pat is going to win $70. So the possible values of X are negative 2 and 70. And the probability that Pat loses $2 is 37 out of 38, because there's 38 pockets, and it's only going to stop in one pocket. The probability that Pat wins is 1 out of 38. So if we multiply the value of X times the probability, negative 2 times 37 is negative 74 out of, should be out of 38. No, I have 78 there. And 70 times 1 out of 38 is 70 out of 38. So on the average, Pat would, if you add these, this is negative 74 plus a positive 70 is a negative 4 out of 38. So 4 divided by 38, 4 divided by 38 is about 11 cents. So on the average, Pat could expect to lose about 11 cents. So Pat's never going to lose exactly 11 cents. Either she's going to lose $2 or she's going to win 70. But on the average, Pat will lose 11 cents. And there's also something called odds in gambling. They talk about odds. So I'm not going to sort of emphasize odds in this course, but it's for the odds, you just it's the ratio of the numerators. So if you take the ratio of numerators, it's 37 to 1. So the odds against Pat winning is 37 to 1. Pat's likely to lose 37 times each for every one time that Pat wins. And here's another example, also involving money. That I put the two money examples on the same video. Tony pays $200 per year for life insurance. If Tony dies, then the insurance company pays $100,000 to Tony's beneficiaries. Life expectancy tables indicate that Tony has a 99.9% chance of living the full year, covered by the $120 premium. Whether Tony lives or dies, the insurance company keeps the $120 premium. Thus, the net benefit to Tony's beneficiaries if Tony dies is $100,000 minus 120, which is $99,880. Let X be a random variable representing life insurance benefits for Tony and Tony's beneficiaries, and find the mean or expected value. So there's two possibilities: either Tony and or his relatives lose $120, or they gain $99,880. The probability that Tony lives and thus loses the $120 is 99.9%, or as a decimal is 0.999. And then, so the probability that Tony dies is 1 minus 0.999, which is 0.001. And then if we multiply each value of X by its probability, this comes out to be $119.88. and 99,880 times 0.001 is $99.88. This is positive, that one's negative. So if you add these, the difference is negative $20. So on the average, Tony or his relatives, his beneficiaries will lose $20 on the average. And that concludes this presentation.